Okay, this is my third video on differentiation, and in this video I will talk about stationary points or turning points. That's another name for it, so I'll just put this on the side and say that it could be called turning points. Alright, so it could be called turning points. Now, I can follow my curve along if I want to. In any way I feel like. However, once I get to this top here, this is called a turning point, or it's called a stationary point, so you can hear any of the two. This is one of my turning points. This is the other turning point here. And what I'll do with that then is then take time to show you that if I'm at this turning point, I am at the maximum value of this curve. So the maximum value given at this turning point, it's not somewhere up there. Maximum value is just there. So all I need is basically to read off what the y value is at that point. That's my maximum value. Just the same way, at this bottom part of my curve, that's my minimum, that's where my minimum value is, that's my minimum turning point. So all I need to do is draw a line across there, read that off, and this is my minimum value. Okay, now a couple of things to know about what happens at that point. If I was to draw a tangent at my turning points, so if I was to draw a tangent across there, just at my turning point, that gives me my minimum value. The gradient of this tangent is 0. And the reason why, well, this tangent will be parallel to the x-axis, and if it's parallel to the x-axis, the gradient is 0. It has no gradient. I should just say the gradient is 0. Just the same way, I could draw a tangent at my maximum value, and for that one the gradient is also 0. So gradient is 0. This is important to remember. It's very, very important to remember because it's going to be pivotal in determining what your stationary points are and how easy it would be to find it. And as you can see, as this is a cubic graph, this has got two stationary points. Not all cubic graphs have two stationary points. Now, here I have some examples that you're going to work through. So feel free to pause the video here and have a go through before I actually start working it out. But what you need to do is find the stationary points. So that's job number 1. Find the stationary point of the curve and then determine if it's a maximum or minimum point. So that's very important. So find it, determine if it's a maximum, minimum point. Okay, lovely. Let's start with the first question. Okay, so here we have the first question. Y is equal to x cubed minus x plus 1. All right, job number 1. Let's go ahead and find out what the gradient is. So we're going to go for dy dx is equal to 3x squared minus 1. 3x squared minus 1. Now, as I've said on the previous slide, at the turning point, my gradient is 0. So it means that dy dx has to be 0 because dy dx is the gradient. So I can say at this point that at turning point, dy by dx is equal to 0. So that gives me the authority now to say that 3x squared minus 1 has to be 0. Now, quick job of solving for x. So I will bring the 1 over, then divide by 3, and let's see where we go. So we're going to have 3x squared is equal to 1. X squared is a third, which means that x is plus or minus the square root of a third. We're not going to work this out, we'll just leave it as plus or minus the square root of a third. Just remember, when you're finding square root, is always the plus or minus. So it means then that this curve has two turning points. One of them is at this point and one's at the other point. So basically, if I was to draw a quick sketch of it, like so, it means that this curve might actually, and notice I say might, actually look like that. And one of my turning points is going to be here, which is positive root a third. And the other turning point might be here, which is negative root a third. So that's fine. We'll go and find out if it's a maximum or minimum. So those are my turning points there. All right, so let's go. If I want to know if it's a maximum or minimum, what I need to do is find the second derivative. And the second derivative basically means this is my first derivative. Once I've differentiated this, this is called my first derivative. To find my second derivative, I need to differentiate this one more time. And it looks like this. D square y dx square. And to find my second derivative now, like I said, I'm differentiating this. So let's differentiate this. This will now equal to 6x, and that is done. Now, before I move on, I must tell you this then. If my, so I'll put this as an aside here, probably in this box. If my second derivative is greater than 0, as in it's a positive number, it means that my turning point is a minimum value, which means that it's going to be down here. If, however, my d square y dx square is less than 0, as in it's a negative number, then it means that that's a maximum value. So let's see what will happen once we start messing around with this. Well, very easy then. I've got x and I've got an x value where the turning point is. The turning point is at that point. So want you to notice that once I make this equal to 0 and I solve for x, what I'm actually finding is the x value at the turning point. So that's the x value at the turning point. I can't stress that enough. Make sure you get that in. Now I don't need to really work this out because it's a very easy job. The minute I put in this root a third there, I will now have 6 times the square root of a third, which will give me a positive answer. Easy job. I don't need to work out the answer. I just need to know if it's positive or negative. It's given me a positive answer, so that tells me that this turning point is a minimum point. So therefore I can say, and so actually they've asked me to find the coordinates actually, so we'll get down to that in a minute. And that tells me that this other one is going to be a maximum. Okay, because when I multiply 6 by a negative number, my answer will be negative, so it will be a maximum turning point. Now, they asked me to find the coordinates, didn't they? So I've already found the x coordinate, the x value, sorry, at that turning point. How do you think I might find a y value? Just a quick guess. Substitute the x value into the original equation maybe, and that gives me the y value that goes there. So let's go ahead and do that. So it means to find the y value, then y will equal to root a third square minus root a third plus 1. A quick job in the calculator will sort that out, which gives me 0.76. So it means that my minimum point or minimum coordinate is root a third and 0.76. Okay, and we can do the exact same thing to find out what the maximum point is, which will be, so this is my maximum point, that's going to be minus root a third and 1.91. Okay, and that ends that problem. We've found the maximum and the minimum point. Now that took a little bit longer than expected, obviously because I had to explain to you how to determine if it's a maximum or minimum point. Okay, now time for you to try one. So we're going to let's get the other one written up. Okay, so here's one for you to try. Find the maximum or minimum point and or. So the first one was a pretty hard one. This one is a quadratic, so you will only probably just get a maximum or a minimum point. Well, think about it. You have a go and see, and then I'll work it out. Pause the video, have a go. Okay, so let's get started then. So my dy dx, which is my gradient, is going to be 4x plus 7 there. And I know that at the maximum or minimum or turning point, let's call it the turning point. So I'm going to say that at the turning point, dy by dx is equal to 0. So that implies that 4x plus 7 is 0. I'll just solve for x really quickly. So it means that x is going to be equal to minus 7 over 4. Okay, so that is the x value at the maximum or minimum point. Now the nice thing about this one, I don't really need to go and find the second derivative. And the reason why I don't is because the coefficient of x is positive, so that already tells me that the curve will look something like that. It will have a minimum value so long as the coefficient of x squared, is positive. But if you want to find the second derivative, by all means, because obviously you might be doing some harder questions. So d square y dx square means now you're going to differentiate this one more time for the second derivative. It's just going to give me the number 4, and once I get that number 4, it is positive, which is proof that you're going to have a minimum value, as I've said before. So anyway, never mind, we've got it, let's move on. Now, it means therefore, wherever that minimum value is, minus 7 over 4, that's the x value for it. What I need to go and do is find a y value for that. That's a very easy job. Just substitute this into my original equation and happy days. So that will now give me y is equal to 2 times minus 7 over 4 all square plus 7 times minus 7 over 4 plus 3. Literally, pop that in your calculator and see where that gets us. So that gives us minus 3.125. We'll just go out for 3.1. So it means that this has a minimum point, and that minimum point is minus 7 over 4 and minus 3.125. I'll just put 3.1 for now. All right, and that's basically it, guys. So on your own, I'm not going to work these out. You've paused the video before and you've written down the other two questions. Have a go at those and see where that takes you. All right, if you have any questions, please let me know. All right, brilliant. Hope that was helpful.